The very first step of working with partial fractions is to use polynomial long division to make sure that the numerator is of lower degree than the denominator, where the numerator is of degree 3 and the denominator is of degree 7, so we're fine there. Step 2, factor the denominator. Great. Next, we have to make a fraction with the denominator of each power of each factor. So this, we have basically two factors. We have x and we have x squared plus 3. But we have 3 powers of it, so we have to have 1 for x to the 1 power, we have to have 1 for x squared, and we have to have 1 for x cubed. And we have to have 1 for the x squared plus 3 to the 1 power, and 1 for the x squared plus 3 squared. And the numerators have to have a general polynomial with variables of 1 degree less than the factor. The factor here is x, so the only thing lower degree than that is a constant, the letter a. The factor here is x. Even though it's x squared, it's still a factor of x, so we only get a single power in the numerator, b, a single constant. Same thing here, c. Now here the factor is x squared plus 3, so 1 degree less than quadratic is linear. We need dx plus e, the most general polynomial of 1 degree less than square. And then same thing here. We also get a linear numerator, so it would be fx plus g. We're not actually going to solve these at this moment. I'm just talking about how to decompose them into partial fractions. This one, well, let's see. The numerator is definitely of lower degree than the denominator. We have to factor it. So it's x plus 4 over what? X squared plus 1, x squared minus 1. We're not quite done yet. X plus 4 over x squared plus 1, x plus 1, x minus 1. And so we have to split it up. We have, what is it? ax plus b over x squared plus 1. And there's only, because that's the most general polynomial of 1 degree less than the denominator, but that has no other powers, so that's the only one. We have only one power of the x plus 1, so c over x plus 1 and d over x minus 1. What have we got here? Oh, we got a doozy of one. We have something over x minus 2 plus something over x minus 2 squared. Every single power of the denominator, that is something over 3x plus 1 plus something over 3x plus 1 squared plus something over 3x plus 1 cubed plus something over 3x plus 1 to the 4th plus something over x squared plus 1 plus something over x squared plus 1 squared plus something over x squared plus 1 cubed. And we need general things. The linear things get a single term, a, b, c, d, e, f. And the quadratic things get general linear equations, gx plus h and ix plus j and kx plus l, unless the I looks too much like a 1 to you, in which case you could use a different letter of the alphabet, but you have that freedom. So hopefully this gives you an idea to how to split them up anyway.